Good evening, students. This lesson is covering the basics of equations of lines. At this point, I am anticipating that this will be the notes for Wednesday's class, possibly Thursday's class. We'll get a little bit better idea as Wednesday and Thursday get a little closer. But for now, I'm anticipating that these will be Tuesday night's notes for Wednesday's class. Let's begin. Our objective this evening will be the student will discover the process and applications of slope-intercept form. Slope-intercept form is not anything that is new to you. It is also one of those things that you have talked about several times in recent years, but I imagine that some of the steps that we will be taking this year are going to be a little bit more complicated than anything that you might have seen with slope-intercept form before. Okay, so let's get to it. All right, now basic information here. Any line that can be graphed has an equation that describes how to graph it. Now, obviously, this is going to be true for any type of thing that can ever show up in a graph, not necessarily a line, but anything. Now, the most common format that you have dealt with before, and that will be true this year as well, is called slope-intercept form. Okay, and slope-intercept form reads y equals mx plus b. Now, m and b represent constants that will show up in the equation of a line. M is the variable that is assigned to represent the slope value of the line, and b is the variable that is assigned to represent the y-intercept of the line. Now, y-intercept means exactly what it sounds like it means. It means where does the graph hit the y-axis? Where does it intercept the y-axis? Okay. Now, the variables x and y in the equation, they are actually part of the equation of the line. And upwards of 99% of the time, the y will be part of the equation in the end, and x will be part of the equation in the end. Okay, so they are not some magical numbers that will be replaced when it comes time to answer a question. They will be there. Your slope-intercept form, like I said, 99 and higher % of the time, your equation will say y equals some number of x's plus or minus some number. So the bottom line is that the line is going to do whatever it does based solely upon the numbers m and b. Okay. Now, before we get into how to do the calculations, I do want to point out that there are two exceptions to what I just said. Now, I said upwards of 99% of the time, that is the way your equations will read. There's only two times that this will not be the case. One of the cases will be in the instance that you run across a horizontal line. Now, as we said in the notes for slope, horizontal lines have a slope value of 0. This happens because the line is running but not rising. That puts a 0 in the numerator of the slope fraction, and any fraction that has a 0 for its numerator has an overall value of 0. So when you plug into slope-intercept form, you will end up with y equals 0x's plus some number, and 0 x's. If there are no x's, then they're not even going to write the x's down in the equation. So the equation of a horizontal line is always going to be y equals, and then you will have a number that emphasizes wherever the line crosses the y-axis. So in the little graph there on the right-hand side, you have a horizontal line, so there will be no x's showing up in the equation. The answer will simply be y equals, where does it cross the y-axis at? It crosses at -4. The equation is y equals -4. That's what a horizontal line's equation is going to look like. Y equals some number. The other flip side of that one is when you have vertical lines. Okay, with vertical lines, your slope value is undefined. We also talked about that in the notes for slope. It is undefined because the line is rising, but it does not run. That puts a 0 in the denominator of the slope fraction. And when you have a 0 for a denominator of a fraction, that is undefined. We have no language to describe a 0 for a denominator. Okay, so if you have an undefined term, you cannot plug an undefined term into an equation. Okay? So what will happen is the equation will simply read x equals wherever the line crosses the x-axis. Okay, this equation will not get a y because it does not make contact with the y-axis. Okay, so once again, the equation will be x equals, where does this line over here on the right cross the x-axis? It crosses at +3, so the equation is x equals 3. That is the only example of a time where you will ever have an x for, an equation that does not begin with y equals mx plus b. This is the only time you'll have an x equals. Okay, let's look at some examples of how the math is going to work surrounding these problems. Here's an example. What is the equation of a line that has a slope of 2/3 and crosses the y-axis at -4? Now this is a very easy example just to get us off and running, get our feet wet. Okay. Anytime we go to write the equation of a line, there are two questions that must be addressed. Okay, and those questions are, what is the slope value and what is the y-intercept value? Those are the two numbers that need to be discovered so we can plug into our equation of y equals mx plus b. Okay, so let's see if we can discover these values. Okay, do we know the slope value for this particular problem? Yes, we do. What is it? It's 2/3. We know this because it was handed directly to us by the problem. The other value we needed to know is, where's the y-intercept at? Do we know where the y-intercept is? Yes, we do. Where is it? It is down at -4. The problem told us that. Okay, so since we have the two pieces of information that are required in order to be able to write the equation of a line in slope-intercept form, all we need to do is plug these into the equation where they go. Well, just like anything else, write down your formula. What is the formula for slope-intercept form? It is y equals mx plus b. All we need to do is plug in the values for m and plug in the values for b, so our equation will read y equals 2/3 x minus 4. Now that one was obviously very easy because the problem came out and handed us the information that we needed. If we were in 7th grade, this would be a perfectly legitimate question, but being in high school, we can probably expect that they are not going to give us anything that easy. So let's look at something that's a little bit more realistic. What is the equation of a line that hits the origin and has a rate of change of -1/2? This is a little bit more of the type of speed that we should expect language-wise from our questions that we may see, but it doesn't change what it is that we're trying to do. We need to know we need to know what is the slope value. We need to know where is the y-intercept at. Well, do we know these two values? Okay, do we know the slope? Well, the problem didn't come out and say, hey, the slope is, but they did give us a synonym for slope. What did they give us? They gave us rate of change. Okay, there's an important term. We talked about this in the notes yesterday, all the different synonyms for slope. Rate of change is one of them. But so they did give us that. The slope is -1/2. How about the y-intercept? Well, they didn't come out and call it the y-intercept, but they did say that the line passes through the origin. Does the origin hit the y-axis? Absolutely it does. Okay, so our y-intercept is going to be at 0. Okay, so once again, they did manage to provide us with the information that we need, so the last thing to do is to write down our slope-intercept form, y equals mx plus b, and then plug in the values where they belong. Y equals -1/2 x. Now, how come they didn't write down the plus b on there? Well, it's really very simple. They're not going to write down a +0 onto an equation because +0 doesn't actually change the equation. And you probably know in math by now, we do not write down information that does not have to be written down. Okay, so if you ever come see an equation that looks like it's in slope-intercept form, but there is no y-intercept, that must mean that the graph is crossing the y-axis at the origin. How about one like this? What is the equation of a line that passes through points 2, 3 and 4, 5 and hits the y-axis at 1? Okay, so we're going to begin this question exactly like we've begun the other two. Okay, we need to know what are the slope and y-intercept values. Okay, so let's begin. How about the slope? Did they give us the slope this time? No, they didn't. Okay, this is going to be probably what you can expect from problems dealing with equations of lines at the high school level. They're not going to hand you the slope value, but we do have an equation that goes with it. We discovered it on the notes from last time. Okay, we have a formula that we can solve for it. How about the y-intercept? Do we have the y-intercept? Yes, this time they gave language that says it hits the y-axis at +1, but that is the y-intercept. Okay, so let's see if we can figure out now how are we going to get this slope value. Okay, well, we have a formula that goes along with it. Okay, so the first thing we're going to do is we're going to take our 2 points, 2, 3, and 4, 5. We're going to label them x1, y1, and x2, y2, just like we've been doing for the last several classes. The next thing we're going to do is we're going to write down our formula, and the formula for calculating slope is m equals the difference of the y values over the difference of the x values. Okay, so now all we have to do is plug in the information exactly where the formulas tell us to. Our y2 is a 5, our y1 is a 3, our x2 is a 4, and our x1 is a 2. Okay, so what's the numerator of this fraction going to be? What is 5 minus 3? Obviously 2. And in the denominator, 4 minus 2 is obviously another 2. So we have a slope value of 2 over 2. Does this reduce? Absolutely it does. Our slope value is going to be 1. Now, that's great. That's not the answer to the problem that they asked. Okay, we needed to know what is the equation of the line. Well, the reason we couldn't write the equation of the line is because something was missing. We were missing the slope value. Do we have it now? Yes, we do. So now we can go to slope-intercept form, y equals mx plus b, and we can write our equation. What will the equation be? Y equals 1x and plus 1. Now, a little side note, did they have to write the 1 in front of the x? Could they have simply said y equals x plus 1? Absolutely. Okay, the reason they don't have to write it down is because the 1 is understood. Just like there's a 1 in front of the y right now. They did not write 1y equals 1x plus 1. So they can easily leave that 1 out, and it would read y equals x plus 1, and that would be accurate as well. Okay, one more example to guide you through here, and then we will have a couple of more that I will need to go over with you in class the next day. So the last example is, what is the equation of a line that passes through points -3, 1 and 0, -3? Okay. Well, once again, we're in the same spot. We'll be in this spot every single time that we're asked about the equation of a line. What is the slope? What is the y-intercept? Okay. This time, did they give us the slope? Well, looking into the problem, you can see that the slope value is not provided, but they did give us 2 points on the line. That is all the information that we need in order to calculate the slope value, so we do have enough information to come up with slope. How about the y-intercept? Did they give us the y-intercept? When you're looking into the problem, okay, it may look like the y-intercept is not provided for you. Okay, but look at the second coordinate that they gave us. 0, -3. Okay, let's think about where 0, -3 is at. That is on the negative y-axis. Okay, so they did actually give us the y-intercept. They just did not call it the y-intercept. Our y-axis intercept is at -3. Okay, but once again, they did not give us the slope value, so here we go again. Okay, we're going to take our 2 points. We're going to label them x1, y1, x2, y2. We're going to bring in our slope formula, m equals the difference of the y's, comma, the difference of the x's. And then we're going to plug in our information where it is called for. Our y2 is -3, y1 is +1, x2 is 0, and x1 is negative 3. Now beware all the negative signs here. Don't go losing any. Very easy to make silly mistakes in here. Now let's look at the numerator here. Negative 3 take away 1. Okay, well, essentially we have two negative numbers here, so we're going to add the numbers together and keep the sign. The numerator will be negative 4. How about the denominator? 0 minus negative 3. Double negative becomes a positive, so the denominator actually reads 0 plus 3, that is positive 3. Okay, so we have negative 4 over positive 3. Okay, we expect slope to be a fraction. We have a fraction here. Now, a lot of people, especially the people that have a habit of using the calculator for every little thing that they do, will try to convert this to a decimal point, and that's not a good idea. Another thing that some folks will try to do is to convert this from being an improper fraction into a mixed number. That's also not a good idea either. We actually need this guy to be a fraction because the numerator means something. It is the rise. The denominator means something. It is the run. So we do not need to convert that any further than it is right now. Let's just plug our values into slope-intercept form. We had the y-intercept. Now we have the slope. So all we have to do is write our equation, and our equation will be y equals negative 4/3 x minus 3. The final two examples, you can go ahead and copy them down. Okay, but they are going to deal with some higher level thinking, and I'd rather just go over this with you in class, but go ahead and copy the examples down. The next one is going to say, what is the equation of a line that passes through points 1, negative 4 and 4, negative 3? Now, you can glance at it real quick and see that they did not give us the slope, and they did not give us the y-intercept in any form or fashion. So that's going to complicate this question a little bit. Okay, but copy it down and then skip down maybe 8 lines or so on your paper and then copy the final example. And that example is, what is the equation of a line that passes through points negative 1, 2 and negative 2, 6? We will cover those two examples in class the next day. And that is the end of your notes for tonight. So I do appreciate you taking time to have a look at them, and I'll see you in class tomorrow.